In this video, we're going to put together some moving platforms. It's actually going to be pretty straightforward. We're going to need two scripts. One script will be used to define a path, an arbitrary path, which will just be a collection of transforms. And the other script is going to be used to attach to an object and reference that path. And that was a very poorly constructed sentence, but what I mean is that script will reference a path object, and it'll also reference an object that it's supposed to control, and it'll move that object along that path over time. We're going to be supporting two methods of interpolation. When I say interpolation, I mean how does it move from point A to point B. We're going to support the move towards and the lerp. The reason for that is the lerp will give us a kind of a different feel for our interpolation, whereas the move towards will make the platform just kind of constantly move towards this next point, hit that next point, move to the next point, and so on and so on. So the first thing we got to do is we have to create our path definition. So the path definition is going to be, like I said, a script that contains a collection of transform objects. So I'm going to say create folder, and I'm going to call this code, where I'm going to place all my mono behaviors inside of. Then I'm going to say create C# script, and I'm going to say path definition. All right, so I'm going to right click and say sync mono develop and wait for it to generate my CS proj. And while it's doing that, I want to point out that the way that we're going to do this, the reason why I'm showing it to you guys is I'm going to show you guys the technique of using the Unity editor and extending it to something that would be appropriate for whatever use case that you have for it. So what we're going to be doing is, in addition to creating the path definition script, we're going to have the path definition script actually in the scene view show the path so that we can see our paths visually. So it's going to be pretty cool. Okay, so we have our path definition created. Our mono develop project is synced, so I'm going to open up my CS proj. What you could do is you could just double click on this and it might work. Let's just do that. Let's go on an adventure. Oh, it did work. Okay, well, typically what I do is I've had so many problems with double clicking on a script within Unity that I generally just go ahead and sync the mono develop project. Then I go into the project path itself and open up buzzsaw c#.slin instead of having Unity launch Visual Studio, because it's had some problems with that in the past. Okay, so our path definition script, again, is just going to have an array of transforms that it's going to reference, and each transform constitutes a point in the world that we want the path to consist of. So the first thing I'm going to do is I'm going to do that, and then I'm going to delete all that. So I just cleared out this entire class. Yeah. So we'll start with an empty class. Then, like I said, the path definition is going to require a public transform points on it. Then it's going to require a public enumerator of transform get paths enumerator. However, I'm going to leave this not implemented, so I'm going to throw a new not implemented exception inside of it. You'll notice that we brought in a couple of using statements up top. We brought in system for our not implemented exception, and we brought in systems collections generic for our enumerator of T. We're not going to implement our get paths enumerator quite yet. We'll do that here in a moment. Okay, so then what we need to do is, again, this path definition is really just a collection of points. So actually we're done. This will do everything we need it to, assuming that the get paths enumerator method were implemented. However, like I said, I want to visually be able to see my points in the editor. So what I have to do is I have to actually hook into an extensibility API provided to you by Unity that allows you to actually draw on the scene view. It allows us to actually go in on the scene view and make whatever sort of visual changes we want to it to make things a little bit more clear for us. So what I'm going to do is I'm going to implement a magic method called onDrawGizmos. The onDrawGizmos method is very similar to the onGUI method in that it's picked up magically by Unity, but all the stuff that we draw inside of onDraw gizmos is actually going to appear in the scene view of Unity itself. So this gives us a really nice, very easy way to extend the Unity editor. It's also important to note that the onDraw gizmos method of every path definition in the scene will be invoked. In addition, we could also implement a method called onDrawGizmosSelected, which will only draw those gizmos if this particular object is selected. Okay, so to draw a line from a collection of points, and those points being referred to as transforms, what we need to do is we need to first ensure that there are at least 2 points. So we say if points.length is smaller than 2, return. That's because we want to ensure that there are enough points to even make a line. Now, you could have more than 2 points, but you need at least 2 points to make a line. Then what I'm going to do is I'm just going to write a simple for loop, where I'm going to say var from equals points 0, or this would be easier actually, for var I equals 1, I smaller than points.length, I plus plus. Then I can say gizmos.drawLine, and then I can say points I minus 1 dot position to points I dot position. So this code actually reads very well. First, we ensure that we have enough points to even make a line. Then we loop all of our points, but note that we start the index on 1. That means we're starting to look at the second point in the array, because we need to be able to reference I minus 1 so that we can draw a line from the previous point to the current point. By doing this, we'll get a nice line from all of our points in the path. So let's go ahead and take a look at what creating a path definition would look like. Coming back into Unity, I'm going to create a game object, create an empty game object, and I'm going to call this object platform path 1. Okay? Then I'm going to create another game object and parent it to platform path 1, and then another game object, parent it to platform path 1, and then create a final game object and parent to platform path 1. I'm going to name the first game object start, I'm going to name the second game object mid, and I'm going to name the third game object end. Note, I'm selecting these objects in my hierarchy and hitting F2 to bring up the rename. So it's a quicker way to do renames inside of Unity. Okay, so we now have start, mid, and end. Let's go ahead and move these guys around. I'll move start to, let's say, over there. I'll move mid to maybe over there, and I'll move end to over here. Now you'll notice that these objects are placed correctly, but we don't have a line. And then we don't have a line because we never actually created a path definition script. So let's go ahead and do that. I'm going to click on my platform path 1 game object, and I'm going to add a component, and I'm just going to type in path definition, and that'll bring up the script I just wrote. We have a slight problem, blah, 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 object reference on 17. It doesn't like 17. Okay, so the points array was not assigned to anything. I slightly forgot about this fact. Sometimes this points array might be null because an array is a reference type, not a value type. And unless Unity stuffs a value into this points array, or not stuffs a value into the array, but until Unity actually instantiates an array for this field, our points object will be null. So I can clean this error up by saying if points equals null, or points.length is smaller than 2. And of course, we're taking advantage of the short circuiting functionality of the OR operator, because obviously if points is null, we don't want to access the length property of points. But because this is an OR, if points is null, it won't execute this second statement or expression. Anyway, coming back to Unity, we are good to go. So I have on my platform path 1 the path definition script, and it has an array of points. Let's go ahead and start adding some points to it. The easiest way to add an array of components or game objects to an array field on a script is to click and drag that object all the way onto that array. And you'll see when I hover over it, points becomes highlighted and my icon changes on my mouse. If I release, we now have one element, the start element. Let's perform that same step with mid. Drag it onto points. We now have that. And let's do it on end. So what we have now is we have an array of these transforms. So when I click and drag, remember, when I click and drag a object onto a field that's expecting a component, it'll grab that component out of that object. What do I mean by that? Well, start, end, and mid are game objects, and all three of them have exactly one component, a transform component. Player platform path 1 has a field on its script path definition that is an array of transforms. So when I click and drag start onto this array, it adds a reference to the start game object's transform component to that array. And now what you can see here is you can see a line. So now I can move this around and we can actually see a line of our platform path, or really any sort of path that we might want to define inside of our game. We can now see it visually represented, and I think that's really cool.
That's very, very handy.
Yeah. We can actually do one more thing to make this even cooler. Let's click on Start, and let's click on a magical tiny button that probably nobody here, or very few people here, have ever realized was actually a button, because that happens a lot in Unity. You see this little box right here?
Yeah, I thought that was a picture.
No, it's a button. You see that little down arrow that you can barely see? Watch what happens when you click on it. It says Select Icon, which allows us to, as you see, while I'm selecting these different icons, notice that Start has now appeared visually inside of our editor. It's not something that's going to appear in the game, but it is something that's going to appear in the editor. So let's go ahead and keep it like this. Also note, you could also use these icons as well, but these icons don't include labels. And since they don't include labels, I don't want to use them in this particular case. So what I'm going to do is I'm going to make a gray button called Start, and I'm going to do the same thing with mid. I'm going to come down here to mid, click this little button that doesn't really look like a button, click that, come down here to end, click this little button that doesn't really look like a button, and then click that. Click off, and we now have our path not only being represented as a line, but also our names being given for our points. In addition, there's one more consequence of giving these guys an icon. They are now clickable. See, before, these game objects were just transforms, and in reality, they really are just transforms. These are worthless well, they're not worthless, but they're game objects that don't exist to provide really any functionality to the game or any visual aspect to the game. They exist solely to be a marker somewhere in the world. But by giving them an icon, we can now click on them, and it makes it a lot easier to modify.
And to think I didn't believe you when you said it was going to be even cooler. Shame on me.
Alright, so now we have our start, mid, and end. Let's go ahead and create our actual script that will receive a reference to a path definition, and then have a game object follow that path. Before we do that, let's look at this get path enumerator. So now that we've seen, now I can actually show you guys visually what the get paths, that should be get path enumerator. Or get points enumerator. No, get path enumerator is good. Now that we can visually see our path, I want to tell you guys what this get path enumerator method will actually do. You'll notice it returns an enumerator. And an enumerator is an object that allows you to examine a property, an object, something, examine something, and then move that something next. That was a terrible definition. A for each loop, for example, uses enumerators because collections, like arrays even, can return enumerators, and those enumerators allow you to look at the current item that you're looking at in the array, and then when you're done with it and you want to loop over, you invoke the move next method, which allows you to get the next item in the array. Well, we're returning an enumerator of transforms, but this enumerator isn't going to be a collection. You might be asking, well, why don't we just return points? Well, the reason for that is the behavior of this path is not going to be like a one-off, go to start, go to mid, go to end. No, what I want to happen is I want the object to start on the first element of the path, move to the next intermediate elements, finally getting to the end element of the path, then I want it to reverse its direction. Then when it hits the start, I want it to reverse its direction again. And then when it hits the end, I want it to reverse its direction again. So the easiest way, using just basic standard C# components to accomplish something like this is to create a custom enumerator that will return an enumerator that gives us that behavior. So the first time we look at the enumerator, we'll get start. We move it next, we get mid. We move it next, we get end. We move it next, we get mid. We move it next, we get start. Move next mid, move next end, and so on forever. So this is an example of an enumerator that will basically just keep on going and going and going and going. It's not a collection because a collection has a finite amount of objects within it. This is a, it's actually better to refer to something like this as a sequence. This is a sequence that we're returning, and the sequence will never terminate.
Basically, the sequence loops.
Yes. Or, well, yeah, loops or ping pongs maybe would be more descriptive.
Yeah, I guess ping pong would be better.
But yeah, that's the basic idea. Okay, so how do we implement this? We're going to use some funky syntax called an iterator block to implement this method. And the iterator block will take the imperative, straightforward code we're about to write and turn it into an object that can be represented or can be invoked as a sequence. If you want to learn more about enumerators, by the way, I have quite a few videos over on 3D Buzz that explains them in detail in the context of using enumerators and iterator blocks, looking at what code actually gets generated by the C# compiler to support them, and also how they're used in Link. Anyway, so let's go ahead and implement this. The first thing I have to do is I have to say if points is null or points.length is smaller than 1. And then you might think, okay, well, if points null or points.length is less than 1, we might want to say something like return null. But no, what we want to do, because this is an iterator block, is we can't use return statements. Instead, we're going to say yield break. Yield break is going to terminate this sequence immediately. You'll notice that here I'm checking to make sure that points.length is smaller than 1. That's because although to draw a line I need at least 2 points, in order to follow a path I need at least 1 point. And a path with 1 point is really just a point, and the object will just sit there and never move. But that is a valid condition, so that's why I'm checking to make sure points.length is, if points.length is smaller than 1, then we yield break. Okay, now we have to write a loop that will continue forever and yield return out those individual points, and more importantly, will ping pong. So I need two variables. I need var direction equals 1. Direction means what direction are we going? Are we going forward or backward? Next, we need var index equals 0. Index is the current index that we're looking at. Next up, I'm going to say while true, because this is going to be an infinite loop. And then I'm going to say while true, yield return points at index. If index is smaller or equal to 0, direction equals 1. Else if index is greater or equal to points length minus 1, direction equals -1. Index equals index plus direction. Okay, so there's a couple, if you've never used an iterator block before, some of this stuff is going to look really bizarre to you guys. In particular, you might notice a non-terminating loop. This while true will go on forever. So you might be thinking, well, this is going to lock up your process and your computer's not going to do anything. Well, because of the nature of iterator blocks, what happens actually is when the execution hits this yield return, that will yield, which is why it's called the yield keyword, it'll yield execution back to whoever is invoking the enumerator. Then they'll get an option to do something. And then when that person who's invoking the enumerator says move next, then execution will resume right here, go all the way down here, hit this end of the loop, loop all the way back to the top, and then it'll yield control back again to the caller. And then when the caller asks for the next element, it'll go and it'll just keep on going and going forever. Notice that's not really an infinite loop in that case, because the controller, the person, or not the controller, the owner of the enumerator, the guy who's asking the enumerator for the next element and the next element and the next element, when he stops asking for the next element, that is effectively the termination of this. So the controller, because we're yielding inside of this loop, the owner of this enumerator, the caller of this enumerator, has control over whether or not it's going to execute again. So let's look at this algorithm real fast. It's really straightforward. We start with direction equals 1, index equals 0. We loop forever. We return back the point that we're currently looking at, which in the first case will be 0. Point 0 is the first element. We then check to see if the index is smaller or equal to 0, meaning that we've hit start again, because start has an index of 0. So if the index that we're looking at is smaller or equal to 0, that means we need to change our direction to 1. Otherwise, if the index is larger or equal to points.length minus 1, then the direction equals 0. So this means that if... Oh, we do have a slight bug in here, but I'll fix that here in a second. If the index is at the end of the points array, then direction equals -1. Then we add to our index based off direction. So if direction is -1, that means we're moving backwards. So adding -1 to the index will go, for example, from end to mid or mid to start. If direction is 1, adding direction to the index will go from start to mid, mid to end. The bug that we have in here right now, though, is if there's only one point in here, then I believe it'll throw an exception. It'll throw an exception because index will be 0, direction will be 1, direction will be set to 1 again, index will be set to 1, it'll loop back around, points at 1 will be an invalid reference. So what I'm going to do here to fix that possible exception is I'm going to say if points.length equals 1, then continue. That's the simplest way to do that, I guess. Anyway, so this getPath enumerator will return a ping-pong pattern of all of the objects in this array. So now let's go ahead and create the follow path script, and that's going to be the actual script that's responsible for taking an object and moving it along the path of a path definition. So let's go into Unity, let's right-click code, or just click code, and say create C# script, and I'm going to create a script called follow path. Then I'm going to come back into Visual Studio, I'm going to say reload all, and I'm going to hit yes. I have to hit reload all is because when I went into Unity and I added that project or that file, Unity regenerated my CS proj, and my CS proj had to be reloaded by Visual Studio. Then I'm going to format this code and remove all of this stuff. So we just have an empty class to work with. Then I'm going to start by creating his parameters and his private variables. So like I said earlier, we want to support two movement types. We want to support the move towards and we want to support lerp. In order to allow the person who's using this component to choose between a move towards implementation and a lerp implementation, we need a data structure that can contain or codify those choices. And what data structure do we use to codify finite choices? Enumerations. So what I'm going to do is I'm going to say a public enum of follow type, and I'm going to give it two members, move towards and lerp. So of course, this won't actually do anything for follow path yet. It's not like if I dump follow path into my inspector, I'll all of a sudden see a follow type. That's because follow type is a type. It's not an instance of a type. So in addition to that, I have to say public follow type. I have to actually create a field that uses this type. And I'll say type equals, and I'll give it a default of move towards. Now, enums will default to 0, and in this particular case, move towards is at a value of 0. However, I like being explicit with my defaults. So even though this is redundant, I prefer the clarity that is provided by being a little bit more explicit. The next thing our follow path needs is a path definition, and we're going to call that path. So the follow path, every follow path component needs a reference to the path definition to know what path it needs to follow. Next up, it needs a speed, and we're going to set the speed to 1 by default. So the speed, not surprisingly, is how fast the platform or object will move. Then I want a public float max distance to goal, and I'll set this as a default of 0.2f. So 0.2 units, that's the maximum distance to a point in the path that is allowed until it moves to the next point of the path. So this allows us to say, okay, well, we're close enough to this point. Let's go ahead and start moving towards the other point. In fact, we can probably just make this point 1f. Next up, we need one private member. And the private member will effectively be this. It'll be our path enumerator. Because our path enumerator object is going to allow us to retrieve the path in the order that we want it to be retrieved in. Let's go ahead and create a private enumerator of transform, and I'll call it current path. You'll notice that I do need to bring in a using systems collections generic in order to use the enumerator of t-type. Okay, next up, I'm going to say, let's not call this current path. Let's call this current point. That's a better name for it, because it's not the current path. Well, it is the current path that we're looking at, but as you'll see in a second, it actually makes a little bit more sense to refer to it as the current point. All right, we need a start method, and if you guys recall, the start method is invoked by Unity once this object has been properly instantiated and configured. And we're going to say if path is null, then let's do if path is null, debug error. Path cannot be null game object, and then we'll say return. So if path is null, that means that the person is trying to play the game, but they haven't given this follow path script a path to follow, which a follow path script without a path to follow isn't a very interesting follow path script. So we'll tell them that they made a mistake. Next step, what we want to do is we want to set our current point to our path.getPathEnumerator. So we want to invoke the getPathEnumerator method and store it in a private variable. Then we want to say current point.moveNext. Now let's look at current point. Current point is of type IEnumerator. IEnumerator has two important methods on it. We'll be ignoring all the other methods on it. Current point has a current property, and if you look at the documentation, it says gets the element in the collection at the current position of the enumerator. Now, I think that they slightly misspoke when they wrote this documentation. It should be gets the element in the sequence at the current position of the enumerator, because we're not, in this case, this is not a collection that we're moving towards. This is a sequence. So we have current, which allows us to look at what we're currently looking at. Wow. It allows us to look at what we're currently... Well, it does. You'll notice that inside of our path definition, getPathEnumerator method, we do things like yield return points at index. What exactly does that mean? That just means that we set the enumerator's current property to whatever we yield returned. So that's why current is important. But what about move next? Well, remember how I said that this yield keyword yields execution back to the controller, or back to the owner of the IEnumerable, or IEnumerator? Well, the move next method on the IEnumerator is actually what accomplishes this. Every time we invoke move next, we'll get another iteration of this method. It's also important to realize that we always have to do a move next first. Then we're going to say if current point dot current equals null, return. We could have also done if current point dot move next equals false, then return. That would have worked as well. So what this says is if we invoked the method, the enumerator, one time for one iteration, and they returned null, just go ahead, or they return null or they return nothing, go ahead and break out of the start method because we have nothing further to do because there were no points in that path. Finally, we'll say transform.position equals current point dot current dot position. So finally, all the way at the end of the start method, we're going to be setting our position of this object to the first point in the path. Okay, so at this point, we now just need to implement our update method. So I'm going to say public void update. The update method is first going to say if current point is null or current point dot current is null, return. That means this object was created either without a path or a path that it didn't at least have one point. If either of those things are the case, we want to early exit out of update because we have nothing to do here. Next up, I'm going to say if type equals move towards, then transform.position equals vector3 dot move towards transform position current point current position time dot delta time times speed. Then we'll say else if type equals lerp, then transform.position equals vector3 dot lerp transform dot position current point current dot position time delta time times speed. And then finally we'll say, well, let's actually talk about these two lines of code first before we move on to the final bit of this method. And that's going to be, we're going to say if type is moved towards, then we're going to move towards that object. So we're going to say transform.position equals vector3 move towards, passing in our current position as the first parameter, our target position as the second parameter, and time.delta times speed as the maximum distance we want to move. Of course, we need to scale by delta time so that our animation of our moving platform will be smooth and not jagged depending on the frame rate. You'll also notice that we do current point dot current. So current point dot current again references the current point that we're looking at. Then if we're on lerp, then we say transform.position equals vector3 lerp transform.position current point current position time delta time speed. So it's the exact same parameters that we're passing in, except we're passing it into a linear interpolation method as opposed to a move towards method. The last thing we need to do is we need to see if we're close enough to the target point that we're considered to be hitting that point, and we need to move to the next element. So I'm going to say var distance squared equals transform dot position minus current point current dot position dot square magnitude. Square magnitude is always going to be faster than getting the normal magnitude, because to get the normal magnitude per the Pythagorean theorem, we need to square root that or perform a square root operation on that return. If we retrieve the square magnitude, then we're basically returning x squared plus y squared plus z squared, which gives us the square magnitude, which is nice because then we don't have to perform that square root operation and it's slightly faster. But when we compare distance squared, we have to make sure that we're comparing it against max distance to goal times max distance to goal. We have to square the other side of the inequality because this side of the inequality is squared itself. Then we're going to say current point dot move next. So current point dot move next will invoke this iterator block again for one more iteration until it hits a yield return. Okay, so I think that just about wraps up our follow path script. So let's go ahead and bring in a platform and plug it in and see if it works. And we'll also see the difference between a move towards and a lerp. I'm going to come back into Unity. I'm going to create two platform paths. So I'm going to come up here to platform path 1 and I'm going to duplicate it and I'm going to move it up. Notice that by duplicating the platform path, because the references to these transforms were childs of this particular game object, or children of this particular game object, when I duplicated it, it changed the references to refer to the duplicated children as opposed to the object that I was initially duplicating from. So that's a very convenient bit of functionality from Unity. We're going to rename this to platform path 2. All right, so let's go ahead and create a platform. I'm going to open up my textures. I think we decided on using our dirt as our platform. Might be able to make it a little bit wider. Okay, so we now have our little platform guy, and we're going to call this platform 1. And I'm just going to stuff him near the start thing. He doesn't have to be at the start point because he'll be moved to the start point on the first frame of the game. But I'll do that anyway just to make it clear which platform follows which path. I will want to set its sorting layer to foreground, by the way. Then what I'm going to do is I'm going to hit add component, and I'm going to say follow path. And the follow path needs to reference a path, a type, a speed, and a max distance to goal. So let's set the follow path for platform 1 to platform path 1. To do that, we simply click and drag platform path 1 onto our path property. All right, let's go ahead and duplicate platform 1. So I'm going to hit Control D, and I'm going to name the duplication platform 2, and I'm going to move him up. Then I'm going to click and drag platform path 2 onto his path. So platform 2 is going to be using platform path 2, and platform 1 is going to be using platform path 1. However, platform path 2, I'm going to change his type to lerp instead of move towards. So we'll get to see the difference between these two. All right, let's go ahead and hit start and see what happens. All right, so we see some interesting behavior here. Well, first of all, everything is working properly, but it's going way too slow. So I'm going to speed that up a bit. I'm going to click on platform 1, and I'm going to give him a speed of like 10. And then platform 2, I'm going to give a speed of like 5 or so. I guess that should be good enough. Let's hit start.
Yeah.
Yeah, I think that's good. But we also have a slight problem. I really want the midpoints of these objects to be these points to be the midpoints of the individual objects, the platforms that are following. So what we can do a couple of things. Well, first of all, we could change the pivot point of this object, which I don't want to do because we had the pivot point set to the lower left for a reason. An alternative is we can make an additional slice that contains another copy of this. I believe we can do that. I've never actually tried to do that, but it might be possible. A third solution is to create a parent game object and use it to set another pivot into it. So what do I mean by that? Well, if I create an empty game object and parent platform 1 to it, I can override the pivot essentially. And then I can prefabify the platform so I can reuse that platform functionality, which I do want to prefabify the platform anyway. So let's go ahead and do that. I'm going to stop the game. Because I want this platform, I want to work on it, and I want to turn it into a prefab, I'm going to position it at 0, 0, 0. Now, we are going to be changing that position here momentarily. I also want to set its scale to 1, 1, 1. So I want it to have a scale of that. Well, let's do 2. I think that would be a good default size for a platform, and then we can resize it later based on our needs. So then what I'm going to do is I'm going to set its position. Instead of 0, 0, 0, I'm going to set it to -1, or negative, let's just eyeball it, -4. So -4 will give it a, we'll put it halfway in between the origin, which is exactly what we want. Then I'm going to go into game object, create empty, and I'm going to call this game object platform. and I'm going to set it at 0, 0, 0. So you'll notice that the game object is in the center of this platform. Then I'm going to parent platform 1 to platform. Then I'm going to do something a little funky. I want the follow path script to be on the parent, not on the child. What I can do is I can simply click and drag follow path from this, and I can just drop it on platform. What do we get? Well, you'll see that the platform 1 game object no longer has that component on it, but platform now has that component on it. Next up, I want to clear out the path. I want to set the path to none. The reason why I want to do that is I want this to be a prefab, and when I instantiate the prefab, I don't want it to have a default of anything inside of it. I just want it to be set to null, essentially, so that I can change the path to whatever I want after I instantiate the prefab. Now that we've created the platform prefab, let's go ahead and jump into our prefabs folder, and I'm going to click and drag platform over here into the prefabs folder, and we now have a prefab called platform. So that's really cool. Let's go ahead and delete platform 1 and platform 2, and then instantiate those prefabs from scratch, configure them, and see what happens. So let's click and drag on platform. Let's bring it out. Maybe that's a little big. Let's set the scale X to 0.5. Or how about 1? No, 0.5. That should be fine. I mean, that's something that you guys can obviously play with to be whatever you want. Then I'm going to set this, I'm going to move this platform over here. I'm going to rename this platform 1, and I'm going to click and drag platform path 1 onto its path, and I'm going to keep it as type of move towards, keep the speed at 10. Next up, let's drag another platform into the game. Let's leave this scaled like that. Let's move it up here near this path. Let's rename this platform platform 2. Let's take platform path 2 and place it on the path. Let's change its type to lerp. Notice how I get a nice little drop down because I have an enum property here. And change its speed to about 5 maybe, because the speed of the linear interpolation will be a lot different than the speed differences from the move towards implementation. Now that we have that, let's hit play. And what do we see? We see our paths now reference the bottom center of these objects. But we indeed see that they move around. In fact, I should be able to just see, I can actually move this guy around. He doesn't actually follow the path, he just goes from point to point. But that's the same thing as following the path if your points don't move. If your points do move, you'll see, again, weird behavior when it tries to, it's like, come back here. I always wondered if it was possible to actually build a game, but the game takes place in the Unity editor. So you extend the Unity editor to be a game, and then you have people download Unity, install your extension, and then it's a game. That'd be kind of fun.
Oh, that'd be kind of cool.
Because I just love doing stuff like this. Anyway, okay, so that's going to be our platforms. A very straightforward follow path implementation. We can see our paths visually only in the scene view, not in the main view. And then we can move the platforms either through linear interpolation or through the move towards implementation. And we can create as many of these paths as we want. So if I wanted to say mid 2 on this, and then duplicate it to mid 3, and then duplicate this and call this mid 4, then I come back into my platform path 1, and then I add my mid 2, or my mid 2 is already added, sorry. I add my mid 3 and my mid 4, and now I hit play, and we'll see that no matter what crazy path you come up with, it'll still just follow, and more importantly, it'll ping pong between the different elements.
That's very cool.
All right, so I think that just about wraps up this video. Actually, I do want to show one thing, what this looks like when you don't see the paths. So I'm going to bring my game camera up here, and then So this is what the game would actually look like if we were playing. All right, so I think that just about wraps up.
Now, I do have a question. Now, in a script setup like this, like in the MMO we're working on, which is 3D, we also have some moving platforms. Can you use a script like you just did here, or is this more of just a basis, or would you have to do a lot more scripting?
Well, the concepts of extending the editor to create paths like this and showing those paths graphically with lines is actually something that's applicable to a bunch of things. Because remember, a game is a lot more than what you just see visually. Because what we're actually seeing is, in this view, just the visual elements of the game. But in reality, there's these invisible paths right here that are placed within the game. In a project like the MMO, that happens all the time where you create these little placeholders or markers or even paths. If we wanted to create a AI where an NPC moved from one location to the other and then back again and over and over and over, how would you do that? Well, obviously the AI and the pathfinding bit would be a little bit complicated, but you would start off with something like this. This would still be something. This is like the basis for anything that you would ever need to mark multiple points in a world for.
Very cool.
All right, so I think that just about wraps things up, and we'll see you guys in the next video.